Good day, fellow coders. I hope you are doing well. Today, let's solve another LeetCode problem. Open the log. In this problem, we have a log with 4 circular wheels, and which wheel has 10 slots from 0 to 9. Okay, if I show you an image, our log will look like something like this, but with the 4 wheels. Okay, initially our log is at this state, that is all wheels are set to 0, and we are given a target state that we need to reach by turning one wheel on slot at a time. And if we are able to get to that target state, then we need to return the minimum total number of turns required. Otherwise, if we can't, then we return -1. Now, what does it mean by on slot? Suppose a wheel is at 3. Okay, now by one slot is means either we can go to 4 from 3 or 2, and not something like that. Okay, 3 from 3 directly jump to 5 or 0. Okay, by on slot means we either increment by 1 or decrement by 1. Okay, we are also given some of the dead ends states, meaning if the log gets one of these states, then the wheels of the log will stop turning and will be unable to open it. So we need to avoid these dead ends states. We cannot put ourselves into one of these dead ends. Okay, now let's see how we are going to tackle this problem. So this is our initial state, and this I represents the ith wheel we are manipulating. Each wheel we can either increment or decrement by one slot. So there will be total of 8 possibilities from here. Okay, so if suppose we increment 0th wheel by one slot, then our next state will be like 1 0 0 0. Okay, and if we decrement this 0th wheel by one slot, okay, now if you see here that our wheel is at this state. Okay, so if we increment by one slot, we go to 1, and if we decrement by one slot, we go to 9. Okay, so maybe rotating clockwise or anti-clockwise would be suitable words. For now, let's stick with the increment and decrement. So it will be 9 and 0 0 0. Similarly, for the first wheel, if we increment by one slot, it will be 0 1 0 0, and if we decrement it by one slot, it will be 0 9 0 0. Okay, and rest will be the same we can do for other 2 wheels. Now from here we can increment 0th wheel by one slot, then our next state will be 2 0 0, and if we decrement our first wheel by one slot, our state will be 0 0 0. Now notice one thing here, we are back to initial state. Okay, and again we will be going from here and here, so we'll stuck in an infinite loop. So we also need to tackle log state we already encountered, so that we never visit again. Otherwise we'll stuck in an infinite loop. And another thing is that suppose this state is one of our dead end state, so we cannot proceed further from here. Okay, now this is our initial source state, that is initial log state, and we can go from like some intermediate state, and then this state, and then again from here another state, and then this. Eventually we reach our target. Suppose this is our final target state, and let's say this is our another state. We can go from here and then finally here. Okay, I'm not showing all of the possibility of the state, it will go out of the screen, so let's stick with this one. Okay, so it seems this is our graph problem, and we move from one state to another state by one slot, and that is one turn, and we set one turn. Okay, so this state will be our node, and this move that will be our this edge weight. Now all we need to find is shortest path from source to target, this, and this will be our shortest path. And whenever we have a graph with equal edge weight, that is 1 in this case, and we need to find a shortest path from source to target. Then we can use standard BFS algorithm to achieve this. Let's implement this. We start by writing function that takes our current state of the log and returns our next state. Okay, so it will be returning a string, and I'm gonna call it increment. That is, we are incrementing ith wheel by 1 slot, and which takes here s is our current state of the log. We need to increment by 1 slot. This will be like, now we need to check if it is already this, I mean like 9th, for example. If our wheel is at 9th and we increment it by 1 slot, then our next value will be 0. So we need to check. If this is the case, then we set it to 0, else we just increment it by 1. Okay, similarly we'll implement for decrement, and that will be, so this will be our decrement, same as increment. Now let's implement our BFS approach. So we have our initial state of the log. Let's call it source, and it will be 40 only. And we also need, as we discussed, we also need to keep track of the visited state. We're going to use unordered set for that, and I'm gonna call it visited only. Now if we mark these dead end states as visited before even starting our BFS on this graph, then we never get to these dead end states. Okay, so we are going to mark all these dead end states as visited. Now one more thing, that in the problem they did not mention if the source or initial state will be in the list of dead ends or not. So it could be or it could not. So we need to check it. We need to check if it is in the visited array. That is, we can simply check search in this way, and if it is in the visited or dead end states, we return -1. Now for BFS we are going to need a queue, and that is, I'm going to a pair of string that represent a state and int. We need to set the initial value, that will be our source, and initially it will be 0, and we also mark this initial state as visited. Okay, so now while our queue is not empty, so our this state, current state, will be like, okay, we get it from the front of the queue, and it will be the first value, and the count, that is minimum required turn, will be this. Okay, if u is equal to our target, then we return this count. Okay, now we pop out our current state. From here we need to determine our next state, and we have 4 wheels to go. So okay, and for each wheel we have 2 operations. Okay, either we can increment or we can decrement, and our next state, let's call it v, will be, okay, if operation is equal to our increment, then we invoke our increment function. Okay, and we pass it our current state and manipulating our ith wheel. Otherwise we call it our decrement function. Okay, now make sure this state is never visited before. So if visited is not count v, then only we push it into our queue, and this will be our, okay, this state and count +1, and mark this state as visited. That's all we need. And if we are out of this loop BFS search and we couldn't get to our target state, then we return it -1. Okay, that's all the code we need to write. So let's run it. It seems our sample cases are running fine, so let's submit it. Okay, accepted. Now let's discuss about time and space complexity. We have 4 wheels, okay, and each wheel can have 10 values, 0 to 9. So each wheel can have 10 values. So total number of combination will be like 10 into 10 into 4 times. Okay, it is nothing but 10 to the power 4. And same, this number of total number of states will be there. So our time complexity will be this, and same will be for our space complexity. If you enjoyed as much as I did, please do like this video and subscribe to this channel. See you with another problem. Bye bye.